us see today exponential distribution. So it comes under continuous distribution. You know binomial distribution, Poisson distribution, geometric distribution or discrete distributions. Uniform distribution, exponential distribution, normal distribution or continuous distributions. So this exponential distribution is a continuous distribution. Let us consider a random variable, continuous random variable capital X. So capital X is a continuous random variable. We say this capital X follow exponential distribution if it has PDF f of x equal to lambda into e power minus lambda x, where lambda is greater than 0 and x takes values from 0 to infinity. So I hope it's clear the definition. X is a continuous random variable and we say this x follows exponential distribution if f of x equal to lambda into e power minus lambda x, where lambda is greater than 0 and x takes values from 0 to infinity. Let us see now the distribution function. You know distribution function is capital F of x. Density function is small f of x. Distribution function is capital F of x. Where capital F of x is p of x less than or equal to x by definition of distribution function. Since x is continuous random variable here, it is minus infinite to x, f of x dx. But we have function only in the interval 0 to x, right? Upper limit is x. See actually the density, this f of x in exponential distribution is lambda into e power minus lambda x, where 0 less than x less than infinity. X takes values from 0 to infinity, right? But here upper limit is fixed, which is x, but the lower limit is minus infinite. But when you look at this here, lower limit is 0. So we have function from 0 to, right? 0 to x. Upper limit is fixed here. So we have to split the interval into 2, minus infinite to 0, 0 to x, where the function is 0 in the interval minus infinite to 0. And from 0 to x, f of x is lambda into e power minus lambda x dx. Integrating, taking lambda outside, integration of e power minus ax is e power minus ax by minus a 0 to x. So substitute limits for, so this lambda and lambda get cancelled. It is minus e power minus lambda x with 0 to x. Substituting upper limit minus e power minus lambda x. So x is replaced x and 0, x is replaced by 0 now. Lower limit is 0. Upper limit minus lower limit. So when 0 is applied, e power minus 0 is 1. So it is minus 1. We have minus here. So already there is minus plus 1. So the distribution function is 1 minus e power minus lambda x. Let us see now memoryless property. Memoryless property of exponential distribution. Okay, memoryless property. So like the memoryless property of geometric distribution, the statement is same, which is like in geometric distribution. So but here it is continuous random variable, and in geometric distribution the variable is discrete random variable. Okay, so x is exponentially, if x is exponentially distributed, this is the statement of this property. If x is exponentially distributed, then p of x greater than m plus n given x greater than m is equal to p of x greater than n. The statement says if x is exponentially distributed, then the statement is same like geometric distribution. There we say if x is geometrically distributed, right? Here it is exponentially distributed. If x is exponentially distributed, then p of x greater than m plus n given x greater than m is equal to p of x greater than n, where m comma n greater than 0. Okay, m and n are positive integers. Let us see proof of the property. So let us take LHS and we shall get RHS answer. So LHS is p of x greater than m plus n given x greater than m. You draw number line. mark m, n, m plus n. If m is 3, n is 5, m plus n is 8. Okay. So we know P of A given B is P of A intersection B by P of B. Okay. Let us find intersection between x greater than m plus n. This is greater than m plus n. This is greater than m. If you see intersection between them, this is the intersection. This is the common area, right? Common. This is common for both. So x greater than, when you take intersection, x greater than m plus n by P of x greater than m. This is our first equation. Okay. So let us now find what is P of x greater than m. And replace m by m plus n, you will get the answer of numerator. So substituting, you will get the required answer. Okay. So let us take P of x greater than m. P of x greater than m, which is integral m to, what is upper limit? Infinity here, right? 0 to infinity is the actual limit. But here it is x greater than m. So m to infinity. F of x dx. Our f of x is lambda into e power minus lambda x for exponential distribution, which is integral m to infinity lambda into e power minus lambda x dx. When you integrate e power minus lambda x, it is e power minus lambda x by minus lambda. Lambda get cancelled. It is minus e power minus lambda x with limit m to infinity. When you substitute upper limit, e power minus infinity 0 minus lower upper limit minus lower limit. When you substitute lower limit for x, it is e power minus lambda m. Already there is minus, here again minus. So it is plus e power minus lambda m. Hence e power minus lambda m is P of x greater than m. P of x greater than m is e power minus lambda m. And when you replace m by m plus n, e power minus lambda into m plus n. E power minus lambda in place of m, write m plus n. Simplify and let us see the answer. Okay. See, P of x greater than m plus n given x greater than m is equal to, and denominator is e power minus lambda m. Numerator is, in place of m, write m plus n. And so you see e power minus lambda m, e power minus lambda n by e power minus lambda m. They get cancelled. It is e power minus lambda n, which is e power, if it is e power minus lambda m, and then it is P of x greater than m. Right? If it is e power minus lambda n, then it is P of x greater than n, which is RHS. Okay. I hope you have understood the property, memoryless property, right? Memoryless property, P of x greater than m plus n, given x greater than m is equal to P of x greater than n, where m and n are positive integers. So when you take LHS, it is P of A given B, which is P of A intersection B by P of B. When you find intersection between them, it is P of x greater than m plus n. Let us find the answer of denominator. Replace m by m plus n in the answer. You will get the answer of numerator. So I have found it is e power minus lambda m. So when I substitute, numerator is e power minus lambda into m plus n. Denominator is e power minus lambda m. Hence cancelling P of x greater than n, which is the required answer. Let us see now MGF, mean and variance of exponential distribution. MGF, mean and variance of exponential distribution. Okay. And now do we find what is the definition of moment generating function? Mx of t is equal to expectation of e to the power tx, which is by definition of MGF. Since x is continuous random variable here, it is integral minus infinite to plus infinite e power tx f of x dx. In exponential distribution, we have f of x only in the interval 0 to t, right? f of x is lambda into e power minus lambda x. In other intervals it is 0. So we need not bother about other interval. So it is right. Taking lambda outside, integral 0 to infinity. When base same, we add powers. While adding powers, it is ctx minus lambda x dx, right? See, it is lambda into e power integral. Listen here, being upper limit is infinity, we know e power, while substituting limit, it must be e power minus infinity, so that it will become 0. If it is e power infinity, then e power infinity is infinity. So in order to substitute upper limit infinity, it must be e to the power minus something, right? So let us take negative sign common and x common. It becomes lambda minus t into x dx. Okay. See, it must be negative sign must be, you must take negative sign common, because when you substitute x for x infinity limit, e power minus infinity will become 0. That's why we have taken this negative sign common outside. Okay. So it is see, integrating, we know integration of e power minus ax is e power minus ax by minus a with limit 0 to infinity. When you substitute upper limit e power minus infinity 0 minus lower limit e power 0 is 1, denominator another negative sign. So lambda minus t. So the answer is lambda by lambda minus t, which is the MGF of exponential distribution. So MGF of exponential distribution is lambda by lambda minus t. Let us see now mean of exponential distribution. That is E of x. What is E of x? It is formula. There are many methods to find E of x. You can use by direct method, integral. E of x is integral minus infinite to plus infinite x into f of x dx. Integrating f of x is lambda into e power minus lambda x. Taking lambda outside and using Bernoulli will give you answer. Or second method, listen here, what is second method? Once you know mu r dash, rth moment about origin, right? Rth moment about origin. Then replacing r by 1, mu r dash we know, which is expectation of x to the power r. Mu 1 dash is e of x. So using this method you can find mu 1 dash, which is mean, right? Or we have another method using MGF. So differentiating once MGF, right? E of x is equal to d by dt of mx of t. Differentiate mx of t once and put t is equal to 0, so that you will get mean. There are many methods to find mean. Okay, let us choose this method since we have found just now MGF, lambda by lambda minus t. So lambda by lambda minus t. Differentiate once the answer and finally put t after differentiation. Finally put t is equal to 0 and you will meet the answer, which is E of x is equal to lambda. So E of x, let us differentiate and we shall check. Okay, it is wrong. Let us differentiate. E of x is, so I differentiate first. Let us see E of x. When I differentiate d by dt of lambda by lambda minus t, then put t 0. When I differentiate, it is u by v method. Keep v, differentiate u, keep u, differentiate v with respect to t, whole divided by v square. Okay. Since we need variance, listen here, if the question is simply mean, you can put t 0 and you can show the answer. Okay. You can show the answer. But we need variance also. In order to find variance, listen here, we have to, let us check. In order to find variance, we need simplified answer. Okay. So before putting t 0, let us simplify this. Minus into minus plus lambda by lambda minus t whole square. Put t 0. So this is the first time differentiation of this lambda by lambda minus t. This is the first time differentiation. Okay. Put t is equal to 0 which is lambda by lambda square. Answer is 1 by lambda. So mean of exponential distribution is 1 by lambda. Next we need variance of the distribution. We know variance is e of x square minus e of x the whole square. Okay, just now we have found e of x. Let us find e of x square. E of x square. There are methods to find e of x square. Let us use this MGF method. Differentiating twice. Differentiating twice mx of t and finally replacing t is equal to 0 will give e of x square. Okay. Just now we have differentiated once, right? D by dt of one time differentiation is lambda by lambda minus t the whole square. Lambda by lambda minus t the whole square. Put t is equal to 0. Okay. Differentiate it again. So keep lambda minus t whole square. Differentiate lambda. Keep lambda. Differentiate lambda minus t whole square. First you reduce power. Then differentiate lambda minus t with respect to t whole divided by lambda minus t whole to the power 4. Put t is equal to 0. And you need not simplify this. We have simplified this answer because I have to use it again here. That's why. But we are not going to use this answer anywhere. So we need not simplify. Let us directly substitute t is equal to 0. This term already became 0. And when t is 0, minus into minus plus, it is 2 lambda. 2 lambda by, when t is 0, lambda power 4, which is 2 by lambda cube. Let us now find variance. Variance is equal to e of x square answer minus, am I right here? Here I have done here mistake. It is lambda into lambda, lambda square, right? Lambda square. So it is 2 by lambda square. 2 by lambda square minus 1 by lambda the whole square. E of x square minus e of x the whole square. So 2 by lambda square by 1 by lambda square is 1 by lambda square, which is the variance of exponential distribution. So mean of exponential distribution is 1 by lambda. Variance of exponential distribution is 1 by lambda square. Let us see now rth moment of exponential distribution. Rth moment of exponential distribution. That is mu r dash. Rth moment about origin. Okay. So which is integral x power r f of x dx. Actual limit is minus infinite to plus infinite. But we have f of x only in the interval 0 to infinite in exponential distribution, which is lambda into e power minus lambda x dx. Taking lambda outside, integrating, am I right? Taking lambda outside, it is x power r e power minus lambda x dx. Let us use gamma function, okay? So we know integral 0 to infinity x power n minus 1, right? X power n minus 1 e power minus x dx, which is gamma n. Or we have another definition by gamma function, e power minus ax, x power n minus 1 e power minus ax dx, which is gamma n by a power n. So we use this gamma function definition to prove this, okay? To prove this. Being here, listen here, it is r. If it is simply 2 or 3, you can use Bernoulli formula to integrate, right? Here it is r, x to the power r. So it is must to use by this gamma function. Integral 0 to infinite x power n minus 1 e power minus ax dx, which is gamma n by a power n. Let us write here, it is lambda into, right? If it is n minus 1, it is n here, right? If it is r, then what it must be? So it is gamma r plus 1. Listen here. If n minus 1, it is n. If it is n, it must be n plus 1. Right? The next to n minus 1 is n. Similarly, next to n is n plus 1. Since it is r here, it is r plus 1. Gamma r plus 1 by a to the power n, right? And here it is, we have, in place of n, we have r here. Our a is lambda. So which is lambda to the power, what it is, lambda a to the power n, right? If it is n minus 1, here it is n. If it is r, it must be r plus 1. I hope you have understood. Listen here. If it is n minus 1, it is n. Next to n minus 1 is n. And next to n is n plus 1. Being r here, next to r is r plus 1. So even in the numerator r plus 1, even in the denominator r plus 1 in place of n. In place of n, it is r plus 1. So gamma r plus 1 by lambda power r plus 1. Since a is lambda here. Okay. So what is the answer? Gamma r plus 1 by lambda power r into lambda, which is lambda power r. Lambda get cancelled. So this is the rth moment, mu r dash, which is gamma r plus 1 by lambda power r. Once you know mu r dash, you can get easily mean, variance, etc. See, mu 1 dash is equal to r is 1, gamma 2 by lambda power 1. You know gamma n is equal to, gamma n is I think n minus 1 factorial. Okay. So gamma 2 is 2 minus 1 factorial, which is 1 factorial, 1 by lambda, right? This is how we have got answer, right? Mean. When r is 2, mu 2 dash is equal to gamma 3 by lambda square. You know gamma 3 is 2 factorial. Gamma 3 is 2 factorial. So 2 by lambda square. Once you know these two, you can find variance, which is mu 2 dash minus mu 1 dash the whole square. So 2 by lambda square minus 1 by lambda the whole square. That is 1 by lambda square, which is 2 minus 1, 1. So variance is 1 by lambda square. Okay. So using MGF, we have found the answer of mean and variance. Now using rth moment, we have found the answer of mean and variance. Okay. So there are many methods to find mean and variance, and this is another method of finding. Okay. So which complete theory part. Next we have to see problems of exponential distribution.